Hello everyone, welcome back to my channel. In this video today, I'm gonna solve problem 606, construct a string from a binary tree. So, this is a medium problem, and whenever you say a binary tree with a difficulty of medium, you're gonna know that this one is a recursion problem. Okay. So the funny thing about those recursion problems is that at the beginning it's gonna feel like this one's impossible to solve, but once you guys have a basic a foundation for the recursion, and then you guys write something down, make some wrap for this, you're gonna see that okay, this one is not that hard. It's just because we haven't thought about it yet. So it's also the same thing with this problem. So with the first look, when you look at the description, you're going to see that okay, so this one is a little bit too much for me. This is a bit too long, so I'm not gonna explain anything there. I'm just going straight forward to the example and give you guys a brief overview about what we have to do. So basically, they give you a tree here, and they ask you to make a string representation of this one. So what is a string representation? You can have a look here. So if we have 1, 2, 3, and 4, we're gonna have like 1 and then 2 parentheses. The one on the left, okay, so let me write something here. So the parentheses on the left is for the left node, the family on the left, and this one is for the family on the right. Okay, so when you look at the left of number 1, the node number 1, you're gonna see that we have 2 here, right? So it's gonna start with a 2 here, and then 2 is gonna open with another 2 parentheses, and by the same thing, what happened here? Okay, so by the same thing, this one on the left is also for the left node of 2, and this one is also for the right node of 2. So what you guys gonna see here, the left node of 2 is 4, and 4 has no other descendants, so we just put 4 here, and the ones on the right is empty, so we just let it there. And let's go back to the right parentheses of 1. You're gonna see that it's just number 3, right? So this one's number 3, so we're gonna put number 3 there. But the thing here is that when you guys have a look back at this, the first parenthesis, you're gonna see that the one on the right of number 2 is empty, so we must delete that. So we have to delete this one. So we're gonna have, well, so what we're gonna have left, we have 1 and then open parentheses, and then 2, and then open parentheses, and we have 4, and in the second parenthesis of 1 we're gonna have 3. So basically that's the idea, and for the second example it's more clear. So we're gonna have 1 here at the root, and then we have two other parentheses. One is for the left and one is for the right. So we're gonna have 2 here, right? So 2 here again. So because the one on the left is empty, so we're gonna put it there, and the one on the right of 2 is 4, so we're gonna put 4 here, and 3 is just lonely, so we just put 3 here. But the thing here is that because the empty node is on the left, so that you guys cannot delete it, because if you can delete that, it's also going to be the same thing with this one at the first example. So in order to distinguish those two trees, what we have to do is that we have to reserve a empty parenthesis on the left. Okay, so that is the idea. So you guys can clearly see the recursion idea of this one is that what we have to do is that we have to have like an idea is that we have to maintain a state like this one. So we have to maintain a state like this one is the root, okay, and this one would be the root. We have to do some recursion, the root to the left, and this one is for the root to the right. Okay, and when you guys are, because you are doing recursion, you guys gonna have to notice at the base case. So you guys gonna see that we're gonna have to stop doing recursion when we stand at the root, and that root has no children. So basically the base case is that you guys stand at the root and there's no root on the left, and also there's no root on the right. So here's going to be our base case. Okay, so we'll write something down here. So the idea is that you guys have to maintain a state like this one for each of the state of recursion, and this is the base case as well. So let me give you guys a right run of how the algorithm would look like. Okay, so we have 1, 2, then 3, and then 4 here. Okay, so let's right run this one first. So step 1, what we have to do is that we have to maintain a state. So we're gonna have 1 and then 2 empty parentheses. So we'll let call the function for the recursion is an f, right? So an f that will receive the parameter, the argument of a root. So you guys can see that we have the 1 here. So the step 1 with that we have to give a state, and we know that this one should be the root to the left, and this one is for the f of the root to the right. So we have to make something like this one if we want our code to work. Okay, so let me delete this one. So because we are standing at 1, so what we have to do is that we put 1 at the beginning, and then for the second one, root to the left is going to be f of 2, and this one will be f of 3, right? So from f of 2 and f of 3, we have to do another recursion. So from here, so we have 2. We have 2 here, and then 2 parentheses again, and then 3 here, so 3 and then 2 parentheses again, and this one's to the left, so it's going to be f4, and this one's going to be our base case. So we're gonna remove that, so it's not gonna have anything here. And for the 3, also I just want to notice that because this one is on the right, meaning it is the second parenthesis, so we can easily delete that. And also for the sub tree on the right, so we're gonna see that there's nothing here as well, so we just delete this one. So we're gonna see that the tree here is the base case, so we just leave it there with nothing new. And then what we have to do next is that with the 4, so from 4 here you guys gonna see that 4 is also a base case, so we just just the result is just 4. So from that you guys gonna go back and you guys gonna see that so 2 of f4 is gonna be 2 of 4. So this one is string of 2 and 4, and this one is just string of 3. So when we put this one back again, we block this one back, we're gonna have like 1 and then 2 and then 4 and then 3. So that's how simple it is. But the thing that you guys need to notice is that when you guys should remove the parentheses, so there's only one way that you guys should remove the parentheses, that is the root is on the right. But if the root is on the left, you guys just leave it there and don't have to delete it. So okay, so let's get to how we can code this problem, and I will give you guys a right run again so that you guys can have an overview of what I have done so far. So this is the base function. So what we have to do is that we have to call a recursive function, and we also have to let the root at the beginning first. I'm going to explain this one later. So just to let you know that we have to have something like this one before we this one has to be adding first. So because those are the 2 parentheses, this 2 1 is going to be recursion function. So just to let you guys know, it can be a little bit confusing, but believe me, when you guys have a look at this this code, you guys can actually understand what I'm doing. Okay, so let's have a look here. So our base case is gonna be if there are no children, we're gonna return an empty string. So why an empty string? So now you guys have a look at this next thing. So let me make something here just to let you guys see. So what we have to do is that we are not going to make a recursion simultaneously on those 2. What we have to do is we have to construct the left first, and then we have to construct the right. So here's the left side, and here's the right side. So you guys can see that it's pretty similar to each other, but the special thing about the left side is that we have this else thing, but on the right we don't have that. So basically, on the left side, we have to generate on the left side we have to generate an open parenthesis like this one. So this is our open parenthesis and this is our close parenthesis, and we have to start with a root value, and then we plus with a recursion function. So if there's no root on the left, I mean this condition and this thing is going to work with only the condition that we have a root on the left, but if not, we have to return an empty parenthesis. And same thing with the right, we have an open here, a close here, and then we start with a root at the beginning and then recursion function to generate everything for us. So basically, that's the reason why I have to put this one here, is because I put the toString before I call the recursion function. So this root value is gonna be contained inside the recursion function, so I have to put it there. We can have a right run real quick here. Sorry for my English. Okay, so let's go to the example, like 1, 2, 3, and then 4. Okay, so let's go to this code. So first of all, we have the function, so return toString of two root value. So we're gonna have 1 here, right? So we'll plus with the recursion function of f1. So we're gonna have 1 plus f1. Okay, so now we check, because f1 is not the base case yet. So what we have to do is that we have to run this function. So firstly, we create a TMP to an empty string, right? Okay, so I'm not going to write a quotation mark there. And then what we have to do is we have to construct on the left. So what we have to do on the left is we have to open the parentheses, and then we call a function, because on the left is 2. So let's remove this one too. So we're going to call f of root to the left, and this is going to be f2, and on the right it's going to be like 3 of f and 3. Okay, so next thing is that with the f2, so f2 we're going to call the f4. So right, so we're going to be 4 of f4, and this one's going to call nothing because 3 is already the base case. So you guys gonna see that when you guys reach 3, you guys are not going to call this function. Actually, that's my mistake. You guys just gonna see that you guys have to look at the base case here. Oh, sorry, we still have to call the function. All right, because because this f3 is called by f1, not by f3. So we go to f3. When you guys go to f3, you're gonna see that the 3 is the base case, so we just have to return an empty string. So actually we don't have anything here as well, so we just return a string here, a 3 here. That's our thing. And from this, what you guys have to do is that from the f4 is a base case, so you guys just return an empty string. So this one is an empty string. Okay, and from where it's go back, so 4 would go back to here, so it's gonna be 4 here, right? And then 2 and 4 would go back to here, so it's gonna be like this. So we're gonna have 1 and then open parentheses for those 2, and then 2, and then 4, and then 3, and then close it again. I mean for this one. So you guys gonna notice that, oh, I messed up a little bit, this one a little bit, but just to let you guys know that our recursion function have to be done from left to right, and only the left side is the one that have some problem, so you guys just need to handle it here. Okay, so that's all for this video. Thanks you guys for watching my videos. See you guys again in another video.